In most modern programming languages, we have the concept of a call stack and a heap. Having a good mental model for these will help you understand your code a whole lot better. In this entire video, we're going to be walking through the same set of sample code and how it interacts with the stack and heap. To briefly go over the code, it's pretty simple. First, we create a function to create people objects, and then we have a function for our main, and inside of our main function, we're going to create two people with different names and amounts of money. We'll see who has the most money. We'll log that. Our main function will be done, and then we'll console log done before ending our application. In our diagram, what the stack is going to be doing is it's going to be keeping track of where we are in code, as well as any variables that we create. The heap is going to keep track of any objects we create, as well as any functions we create. Walking through this code line by line, on the first line of code, it's really this entire block of lines 1 through 6 where we're declaring this function createPerson. The function itself isn't going to be run. Instead, what we're doing is we're creating this function, and the function will get stored in the heap in its entirety. Next, we move on to lines 8 through 14, where we do the same thing. We create a function named main. This function doesn't run right now. The function in its entirety gets saved to the heap as a function that we can later call. On line 16, now we start to invoke the main function. So when we invoke the main function, the call stack will get a new frame. The first frame is this index.ts file, keeping track of what line we're on. And when we invoke this function, we get a new frame for the main function, which tracks where inside of this main function we are, as well as any variables that are created within that function. So on the first line of this function invocation, we create a variable p1. And on this line, we call the function createPerson, which will add another stack frame to track where we are inside of that function. Whatever the latest function call is going to be our active stack frame. So in this function, we're creating a person object. And when we create that object is going to get created in the heap. That object gets returned from the function and assigned to the variable p1. So this variable p1 references this object on the heap. Next, we do the same thing with p2. We create a person. That person object gets created. It returns back to this main function. And p2 now references this second person object. Afterwards, we have this line to create a variable most money, and most money is also calling functions. Those functions weren't created by us. They already exist as a library that we have access to in TypeScript, but we'll still call that math.max function. It will get a stack frame, and when it runs and returns, we'll get the value assigned to most money. Now, typically speaking, primitive values such as numbers are just going to be stored in the stack. So the stack will keep track of the variable as well as the number assigned to the variable. Afterwards, we'll call the console.log function, which once again will add a new stack frame for that log function. And when the log function is done, it will return execution back to our main function. And this is the last line of our main function. So now the main function frame will be removed from the stack. And when that main function was removed from the stack, we no longer have any references to these two person objects. At this point in time, TypeScript can remove these objects from memory. It might happen immediately. It might take some time before they're actually removed. What we're simply saying right now is these objects are no longer referenced, and TypeScript can freely remove them from memory as needed. Continuing on, we have one more log statement, which will get its own frame on the call stack, and then our application will be done, and the program will be over.